Malia can paint 7 fence boards in a half hour. So what are the two things that we're working with here? We're working with boards, fence boards, and hours. So one of the things that a lot of students got wrong, and not really wrong, but we need to learn the conventions of math, is that we put the input, whatever the input is, and the output here. So we have to think about this situation. The situation, Malia is putting in hours of work and producing fence boards. So my input is hours of work. So we're going to put time here. And I always like to start with my table before I do any of the rest of this stuff, because the table organizes my data. So I have time, and that's in hours. And then I'm going to have boards. What do we know? We know that a half hour produces 7 boards. So 1 hour is going to produce 14 boards. 2 hours, if 1 hour produces 14, 2 hours will produce 28. 3 hours will produce 42. Okay, so what is the relationship between this input and this output? To go from 3 to 42, I multiply by 14. 2 to 28, multiplying by 14. 1 times 14. A half times 14 gives me 7. So I'm taking whatever this value is and multiplying it by 14. So we just write that as 14x. Okay. Now, from here, I've got everything I need to fill out my rule, what my x is, what my y is, and to figure out my constant of proportionality. My rule is right here, right? This is x, and this is my output, y. So my rule is y equals 14 times x. What is x? X is time in hours. You can get your information from your data table. Time in hours. And what is my y? What is my output? That's boards. Okay, fence boards. Sorry that that's auto-focusing so much. The constant of proportionality is whatever we're multiplying the input by to get the output. So that's the 14. Now, the graph. We need to make sure we're very explicit on the graph so that if anybody is reading it and they don't have any other information, they know what's happening. Okay. First thing, this is my x-axis. This is my y-axis. I need to label what those things are, the quantities. So x is time in hours. So we have to label this down here, time in hours. And this axis is y. It's the number of fence boards. So I'm gonna go ahead and write number of boards. Okay. Now we've got to get this data onto this table. My x values are pretty easy, right? I have to go from essentially 0 to 3. Now this point here is 0 on the x-axis and the y-axis. This is 0. A lot of people were making this 0. This right here, what we call the origin, that is 0. We have negative, positive. So I need to have a half on there, so I'm going to go ahead and make this 1, this 2, and this 3. So what that shows is that this is a half to 1, 1.5, 2, 2.5, 3. We have to be consistent all the way through. Each one of these tick marks is a half. We can even label this one if we want, a half. Now this scale, we can make it whatever we want to fit this data. But here is what some people did. They made this 7. Okay. No, I'm sorry. Yeah, they made this 7. And then they made this 14. And then they made this 28. If you do that, let's look at what I just said. Made 7, 14, 28. That doesn't work because now you're saying that this tick mark is 3.5 to 7. 3.5 more gets me to 10.5. 3.5 more gets me to 14. But then 3.5 more gets me to 17.5. 3.5 more would only get me to 21. So you have to be consistent. Okay, this would need to be 21. 28 wouldn't be till here, and you wouldn't get 42 on your graph. So what we're going to do, we'll make each one of these 7. So that's 7. Here's 14, 21, here's 28. Okay, add 7 more, you get to 35. 7 more, you get to 42. And I think we're done. We've got everything we need. Okay, so now we're going to plot our points. 1/2 is 7. You can even mark this 7 if you want. 1 hour is 14. 2 hours is 28. 3 hours is 42. Okay. There was some confusion whether this was proportional or not. If you extend this line, it is going to go through 0, 0. Okay, we could have put that on the data table, but we didn't need to, right? 0 hours would produce 0 fence boards. So we're going to go ahead and draw a nice straight line, extending. And there is my graph.